Let us complete this integration. 0 integral from 0 to 1 of x squared minus x cubed dx. What will this give us? This will be, first of all, you could separate them or you could do it all at once. Let's look at both situations. Let's do both of them at the same time. X squared, when you integrate x squared you get x cubed divided by 3 minus, when you integrate x cubed you get x to the 4th divided by 4, and you're going from 0 to 1. So here you have x cubed, which is 1 cubed over 3 minus 1 to the 4th over 4, that's using the 1 upper boundary, minus, then we use the 0, the lower boundary. It will be 0 cubed over 3 minus 0 cubed over 4. So what you have is 1/3 minus a quarter. Both of these will be 0, so you're minus 0. You don't need to write the minus 0 here. So you have 1/3 minus a quarter. What is this? 1/3 minus a quarter. You find the LCM of 3 and 4. 3 into 4 goes 4 times 4, 1, 4 minus 4 into 12, 3. 3 ones 3. Just doing some fractions here. 4 minus 3 is 1. Alright, so the answer is 1/12. So you get 1/12. Now we're saying that we're also going to integrate them separately. So let's see what would happen. The integral from 0 to 1 of x cubed over 3 dx, or minus the integral from 0 to 1 of x to the 4th over 4 dx. So that would be x to the 4, no, x cubed over 3 from 0 to 1 minus x to the 4. Oh, wrong thing I'm doing. I'm looking at what was already integrated. I should be looking back at this. Right. So let's go with it properly now. Integral from 0 to 1 of x squared dx minus integral from 0 to 1 of x cubed dx. Alright, good. So we have x to the 3 over 3 from 0 to 1 minus x to the 4th over 4 from 0 to 1. Then what we have next is 1 cubed over 3 minus 0 cubed over 3 minus, and then 1 to the 4th over 4 minus 0 to the 4th over 4. So what that will give us is 1/3 minus 0 minus, this minus now, a quarter minus 0. So we have 1/3 minus a quarter, same thing. 1/3 minus a quarter is 1/12. So in that case, it doesn't matter whether we bungle both functions and integrate at once, or we integrate one function minus the other function. But anyway, this 1/12, remember this is a definite integral. So this 1/12 would represent a certain area. Now what area would it be? Remember, we're looking at the integral from 0 to 1 of x squared minus x cubed. Let's look. I've already plotted x squared and x cubed on the same graph, so let's look at it. Alright, so I'm not seeing my pens, so let's go again. Okay, good. So in this case, what we have in green is y equals x squared. So in green, we have y equals x squared. In black, we have y equals x cubed. Now, from 0 to 1, this is 0, 0 here, and this is 1. Here, what we're looking at. Alright, what we're looking at here, the answer we got, 112, would represent this area, this shaded area. Alright? It's the area between both curves, because we have two functions. Before, we used only one function, so it was the area between the curve and the x-axis. But in this case, we have two functions. So it's the area between one function and the other. Now, you can see that x squared, between 0 and 1, x squared is higher. And the x cubed is lower. So it's this area that we really are looking at. Now, the answer here, the area, is 112 square units. You could write it as decimal as well. What is 1 over 12? Let's see. 1 divided by 12 equal 0.83, and the 3 goes on. You see? 0.083, and the 3 goes on and on. So it's 0.083. Going to use a dot above the 3 to show that it continues on and on. So 0.083 units squared. Now let's look at something. Suppose we integrate from 0 to 1 of x squared, then integrate from 0 to 1 of x cubed and subtract them. It should give you the same area. Look at this. This is the integral from 0 to 1 of x squared minus then the integral from 0 to 1 of x cubed. It's each function integrated separately and then subtracted, and you notice what it did? Gave the same area. Alright? So, given two functions, the graph of two functions, what you will do is find the integral, where if you're asked to find the area between them, just find the integral from x equal this value to x equal the other value, and then do your calculations from there. Alright? So, I end this video at this point, and we continue discussing this in the next video.